Hello, and welcome to the AI Research Roundup. I am your host, Alex. Today is June 5th, 2025. We're looking at a fascinating paper from Hugging Face's trending list, published just yesterday, June 4th, Advancing Multimodal Reasoning, from Optimized Cold Start to Staged Reinforcement Learning. This paper explores how to truly unlock complex reasoning in multimodal large language models. It highlights that a strong text-based initial setup, a good cold start, is critical for things like chain-of-thought reasoning, where models explain their thinking. It also examines how standard group relative policy optimization, a reinforcement learning technique, can suffer from gradient stagnation, slowing progress, and how later text-only training boosts reasoning further. Alright, to illustrate their success, the authors present this first figure. It's a bar chart comparing accuracy for several open-source reasoning models across a range of tough multimodal and textual benchmarks. Their model, ReVisual-R1, is the distinct orange bar. These models are Multimodal Large Language Models, or MLLMs, AI systems that understand both text and images. You can see ReVisual-R1 generally outperforms others, notably achieving a much higher average. This supports their claims about boosting complex reasoning, like chain of thought, where a model explains its steps, using methods like reinforcement learning, which is essentially AI learning by trial and error with rewards. Building on that overall performance, this next figure, Figure 2, highlights the critical initial setup. The research tackles issues like gradient stagnation, where model learning stalls, often seen with group relative policy optimization, or GRPO, a reinforcement learning training method. Figure 2 focuses on cold start initialization, the model's foundational training. It clearly shows that text-only cold starts yield significantly better performance gains on reasoning tasks, emphasizing the importance of a strong text-based start before more complex multimodal training. So to achieve that strong text-based start, this Table 1, details the sources for their newly curated dataset called Grammar. This dataset is key to their staged reinforcement optimization framework, which is their novel three-phase training method. You can see it's divided into multimodal sources on the left and text-only sources on the right, listing various datasets like Figure QA, Open Thoughts, and Deep Math, along with the number of samples. This diverse text data, especially for reasoning, builds that crucial reflective capability and chain of thought foundation we talked about. Okay, so after curating that grammar dataset for the initial cold start, or CS, which is that foundational training phase, this Table 3, presents an ablation study. An ablation study is where researchers test different combinations of their methods parts to see what works best. Here, they compare different sequences of training stages: the cold start, then multimodal reinforcement learning, or MRL, which connects text and vision, and finally textual reinforcement learning, or TRL, to refine language. The results clearly show their full sequence: cold start, then multimodal reinforcement learning, then textual reinforcement learning, achieves the highest average score, validating their staged reinforcement optimization approach. Now, drilling down into that multimodal reinforcement learning stage, this Figure 3, plots the reward or accuracy over training steps for different strategies. The authors specifically wanted to tackle gradient stagnation, that problem where learning stalls, with group relative policy optimization. You can see their proposed prioritized advantage distillation, or PAD sampling method, the solid purple line, consistently achieves higher rewards and converges, or stabilizes, much faster. In contrast, the standard group relative policy optimization baseline, the dashed dark blue line, shows significant dips. This really underscores how prioritized advantage distillation improves training stability and efficiency. Alright, so we've seen how prioritized advantage distillation refines the multimodal reinforcement learning. Now let's look at what this all leads to in practice. Figure 6 provides a fascinating case study of the ReVisual-R1 model tackling a visual reasoning puzzle. The output isn't just a final answer, it's a detailed thought process. It uses special markers like a think token, a reflection token, and a self-critique token to articulate its steps of hypothesizing, verifying, and correcting its own reasoning. This really illustrates that reflective, step-by-step reasoning capability the authors aim to build. So as we've seen with the impressive ReVisual-R1 model, this work really hammers home a key point. A thoughtfully designed training process, like their staged reinforcement optimization framework, is crucial for unlocking advanced reasoning in multimodal large language models, those models that understand both text and images. It shows that smart curriculum design and targeted fixes for training hurdles, such as addressing gradient stagnation, are what truly push performance forward, not just model scale. Thanks for tuning in to this AI Research Roundup. I am Alex and Catch you next time.